Grade 10, 11, and 12 simultaneous equations. So I got an example here, the simultaneous equations problem. So we're just going to solve it. I'm just going to show you how to solve it. So the first equation says x is equal to 2y plus 2. And the second equation says x squared minus 2xy plus 3y squared. 3y squared is equal to 4. So I'm going to do this in two methods. The first method I'm going to do it with is substitution method. And the second method that I'm going to utilize is the elimination method. So let's start with the substitution method. So with the substitution method, we're just going to substitute the equation in which we have written x as a subject of the formula or y as a subject of the formula, and then substitute that that equation into the second equation. For example, the first equation here, we already have x as the subject of the formula, so we're just going to substitute wherever we see x, 2y plus 2. What I mean by that is, into the second equation, wherever we see x, we're going to put 2y plus 2. So x squared here, because x is 2y plus 2, we're just going to put 2y plus 2, then square that, minus 2y, wherever we see x, we put 2y plus 2, then plus 3y squared is equal to 4. In that way, we only have one variable to solve for, which is y in this case, right? So we just solve for y, right? So we're just going to expand this using a FOIL method. So 2y plus 2 multiplied by 2y plus 2 minus 2. Okay, well, let me just multiply this whole thing out, right? So negative 2y multiplied by 2y, it's negative 4y squared. I hope that you can see that. Negative 4y squared. Negative 2y multiplied by positive 2 is negative 4y. Then plus 3y squared is equal to 4, right? So we're just going to utilize the FOIL method to multiply this whole thing out. Meaning 2y multiplied by 2y, then 2y multiplied by positive 2, and then positive 2 multiplied by 2y, and then positive 2 multiplied by positive 2. That is the FOIL method. So 2y multiplied by 2y is 4y squared. 2y multiplied by positive 2, it's 4y plus 2 multiplied by 2y, that's 4y, plus 2 multiplied by 2, that's 4. Then I'm just going to collect the like terms because here we have negative 4y squared, and we also have 3y squared here. There we consider them like terms because they have the same variable y squared. So negative 4 plus 3, that's negative 1. So negative 1y squared, then minus 4y. Then let me just bring 4 from the right hand side to the left hand side. Let me just transpose it. So it's going to be negative when we process the equal sign. So that's equal to 0. Now let me collect all the like terms. I can see that I have the same variable here, y squared, and also here. So I'm just going to add those. So 4y minus y squared, that's 3y squared, right? And then here I have plus 4y minus 4y. So 4y plus 4y is 8y, right? 8y minus 4y, that's 4y. So we got plus 4y here. And then the remaining ones. So we have plus 4 minus 4. So 4 minus 4 is 0. So we're not even going to write that. So that's equal to 0. Now let us just factorize this because we have the same term here, or variable, which is y. We can just take it out as a common factor. So y outside, then to get 3y squared, we multiply y by 3y, and to get 4y, we multiply y by 4. That's equal to 0. In this case, we're going to utilize the identity of 0. That means y is equal to 0, or whatever that is inside the bracket is equal to 0. So that means 3y plus 4 is equal to 0, right? So we're just going to transpose 4 to the right hand side, and it becomes negative, and then divide both sides by 3. So now y is equal to 4 over 3. So that means we have two values of y for the simultaneous equation, right? We don't know what x is. However, the first equation says x is equal to 2y plus 2. So for every y value that we have got, we're going to substitute it to get corresponding x value. So for y is equal to 0, x is going to be equal to 2. Wherever we see y, we put 0 plus 2. Where do we take this from? We take it from the first equation. So x is equal to 2 multiplied by 0 plus 2. 2 multiplied by 0 is 0 plus 2, that's 2. So x is equal to 0. X is equal to 2 for y is equal to 0. What about for y is equal to negative 4 over 3? So for y is equal to negative 4 over 3, x is equal to 2 multiplied by negative 4 over 3 plus 2. If you're in an exam, you don't want to waste any time, press a calculator. But because I don't got a calculator with me right now, I'm just going to utilize my manual method of doing it. So negative 4 over 3 multiplied by 2, we have negative 8 over 3 plus 2. 2 is 6 over 3, so negative 8 over 3 plus 6 over 3, that's negative 2 over 3. So for y is equals to negative 4 over 3, x is equal to negative 2 over 3. So now we have solved our simultaneous equation. So that means that for x is equal to 2, y is 0, and for x is equal to negative 2 over 3, y is equal to negative 4 over 3. So that's how we solve the simultaneous equation using the substitution method. So next I'm going to do the very same thing. We have to get the same values, but I'm going to solve it differently. I'm going to utilize the elimination method. Okay, with the elimination method, we still have x is equal to 2y plus 4. Oh, it's plus 2. I'm sorry about that. It's plus 2. Yes. And then we have x squared minus 2xy plus 3y squared is equal to 4. 3y squared is equal to 4. Okay, well, in this case, we're not going to be able to utilize the elimination method. I want you to be able to realize when and when not to utilize the elimination method. So in this case, we cannot utilize the elimination method, and I want to tell you why. The reason we cannot utilize the elimination method, it is because here we have a linear equation. So the first equation is linear because the highest exponent that we have is 1. X is to power 1 and also y is to power 1. So that's a linear equation. For the second one, we have a quadratic equation where the highest degree of the exponent is 2. So x highest degree of exponent is 2 and y's highest degree of exponent is 2. So that's quadratic equation. So if we have two different types of equations, not when we have two different equations, when we have two different types of equations, we cannot use the elimination method. We cannot utilize the elimination method if we have two different types of equations. However, if these equations were the same, what I mean by the same is were the same type, meaning if we had both linear equations or both quadratic equations, then we're going to be able to utilize the elimination method. But because in this case we don't have the same type of equations, then we cannot utilize the elimination method. Let me find, just for the convenience of it, for me to be able to explain to you how the elimination method works, let me find an elimination method equation types and then trying to solve it for you to understand this. Okay, so I have found a very beautiful simultaneous equation example. So I'm going to utilize two linear equations where I'm going to be solving for them by using elimination method, right? Because I guess it is very difficult to find a quadratic equation where you're going to be able to solve for both x and y simultaneously using elimination method, right? So example that I have here with me is 3y minus 3 is equal to negative 2x. That's our equation 1. And then equation 2 is 4x plus 4y is equal to negative 2, right? So the first thing that I want to point out is the fact that these two equations are linear. I'm sure you can notice that as well. The highest degree of exponents for both equations is 1. So we have y to the power 1, x to the power 1, x to the power 1, y to the power 1. So the highest degree of exponent is 1. So that means that they're both linear. So if they're both linear, that means elimination method qualifies, right? We can be able to apply it here. So let us get into this. I have a problem though. I don't know if you can notice it. These two equations are not arranged in a way that will be convenient for me to be able to solve them, right? So I have to rearrange them. As you can see that in the first equation, x is on the right hand side and it is on the left hand side on the second equation, right? Even though in both equations y is on the left hand side, how the x is on the right hand side on the first equation and on the left hand side on the second equation. So I have to make sure that x is on the same side on both equations, right? So what I'm gonna do is take x to the left hand side and then take the constant -3 to the right hand side, because the constant on the second equation is on the right hand side. So I'm just gonna rearrange. That's the first step that I'm gonna do. So rearranging this, because x is 2x is negative on the right hand side, it's going to be positive on the left hand side. What I mean is we're going to have positive 2x, then plus 3y, then I'm going to take -3 to the right hand side. So when it crosses the equal sign, it becomes positive. So we're going to have 3, right? So that's going to be our first equation now. We have rearranged it. And then the second equation remains the same. It's 4x plus 4y is equal to -2. Now this looks better, doesn't it? Right? So rearrangement is the first step that I did here. And then the second step that I have to do is, because this is elimination method, I have to eliminate either x or y by making sure that the coefficient of both the coefficient in both equations for x are the same, or the coefficients for the coefficients of y in both equations are the same, right? So I'm gonna do this in terms of x first. So I'm gonna make sure that the coefficients of x in both equations are the same. So in the first equation we have the coefficient of x as 2, and in the second one we have coefficient of x as 4. So I have to make sure that, because 4 is greater than 2, let me just multiply everything on the first equation by 2 to make sure that the coefficient of x in the first equation is the same as the coefficient of x in the second equation. That means 4. By so saying, let me just do it straight away. So I'm multiplying everything on the first equation by 2 to make sure that the coefficient of x in both equations are the same, right? So that means that we're going to have a new equation 3. So the equation 3 is going to be everything on the first equation multiplied by 2. So 2 multiplied 2x is 4x, 2 multiplied 3y is 6y, equal to 2 multiplied 3 is 6. Now that's our equation 3, right? Now that we have equation 3, forget about equation 1 now, because we have manipulated it, right? So focus on the newly formed equation. So now we have equation 2 and 3 that we should focus on. Equation 2 and 3. Forget about 1 now, because 1 have helped us get to equation 3. Now what we have to do is subtract the third equation from the second one. So we're going to subtract the third equation from the second one, meaning the second equation minus the third equation. By so saying, we're going to have this result: 4x minus 4x, that's 0. That means that we have indeed eliminated what? X. So we no longer have x as a variable to solve for, right? And then now we're going to have 4y minus 6y, right? So this negative here multiplies everything that is inside the bracket on the third equation. So negative multiply positive, that's negative. So that means 6y is negative. So 4y minus 6y, that's negative 2y, right? Equal to, and then negative 2 minus 6. Negative minus 6 is negative 8. Now we can solve for y. So y is the only variable that we have left to solve for. So dividing both sides by negative 2, we get y to be equal to 4. So now y is 4. So we have solved for y. Because both these equations were linear, we're only gonna get one value of y. unlike the equation that we have done previously where we were solving for this simultaneously using substitution method, we got two values of both y and x, but in this case we're going to only get one value of each x and y because these equations are both linear, right? So you know that linear equations only touch once at a point of intersection. They don't touch too many times, they only touch once. They only touch, intersect, or cross each other once. So the value of intersection is going to be 1 point. That's why we only have one y value, and expectedly we're also going to have one x value. So how about x? So to solve for x, we go to any equation, either equation 1, 2, or the newly formed 3. They're all going to give us the same answer, right? So let us go to equation 1 for our own convenience. So 3y minus 3 is equal to negative 2x. We're solving for x here. Now that we have the value of y, we can just substitute it into the equation. 3, wherever we see y, we put 4, then minus 3 is equal to negative 2x. 3 multiplied 4, that's 12. 12 minus 3, that's 9, is equal to negative 2x. So dividing both sides by negative 2, we get x to be negative 9 over 2. So now x is negative 9 over 2 and y is 4. So that means that the point of intersection that we are looking for is negative 9 over 2 is 2, 4. Right? So we have solved for this using elimination method. However, we eliminated what? X. Right? So I'm going to do the very same thing, eliminating y in this case, to see if I'm going to get the same answer, right? So let me just redo this thing. We had 3y, let me just confirm, minus 3 is equal to negative, was it negative 2x? Okay, negative 2x, and we had 4x, was it plus? Yeah, plus 4y is equal to negative 2. I just want to confirm that. Okay, cool. So now we're going to do the very same thing. However, in this case, we're going to eliminate y. So the very same way we did, we rearranged the equation 1 in the first example. I'm going to do the very same thing here. So I'm going to rearrange. So taking negative 2x to the left hand side, we're going to have positive 2x, then plus 3y, and then taking negative 3 to the right hand side, we're going to have positive 3. So that's equation 1 rearranged, and then equation 2 is going to remain the same, right? And then now when we get here, remember, we're going to manipulate equation 1 so that we have the same coefficient of the same variable that we're trying to eliminate in both equations. So because in the first equation, in the first example, we eliminated x, in this example we're going to eliminate y, right? So to eliminate y, we have to make sure that in both equations the coefficient of y is the same, right? So in the first equation, this is equation 1 and this is equation 2, right? So we have to make sure that in both equations the coefficient of y is the same, right? So in the first equation the coefficient of y is 3, in the second one is 4, right? So in that case, because 4 and 3 are not much related, yeah, they're not each other's factors, right? Or each other's multiples. So they're not multiples nor factors. So what we have to do is apply the LCM principle, the lowest common multiple. So the lowest common multiple between 3 and 4 is when we multiply both of them. So 3 multiplied by 4 is 12, right? So how do we get 12? We multiply 3 by 4. So that means we're going to multiply equation y by 4. And then to get 12, we multiplied 4 by 3. So that means we're going to multiply the second equation by 3. In that case, or in that way, we're going to have, in both equations, we're going to have the coefficient of y as 12. Okay. Now doing that, the newly formed equation 1 is going to be 4 multiplied by 2x, that's 8x. You know this. 4 multiplied by 3y, that's 12y, is equal to 4 multiplied by 3, that's 12. And then on the second equation, 3 multiplied by 4x, that's 12x, plus 3 multiplied by 4y, that's 12y, and then 3 multiplied by -2, that's -6. Right, now we have new equations. After this is subtraction, right? So we're going to subtract the second equation from the first. So we're going to say the first equation minus the whole of the second one. So 8x minus 12x, that's -4x. 12y minus 12y, that's 0. So that's how we eliminate 12y, or that's how we eliminate the y variable. So -4x is equal to 12 minus -6. So negative multiplied by negative, that's positive. So this 6 is positive. So that means 12 plus 6. How much is that? That's 18. Right? And then now we divide both sides by -4. So x is going to be equal to -18 over 4. And then simplifying that, we're going to get, dividing both sides by 2, we're going to get -9 over 2. So that means x is equal to -9 over 2. And then what about y? For y, we're just going to substitute wherever we see x, we're going to substitute -9 over 2 in any of the equations. But because we did in the first example, we substituted y in the first equation, we're also going to do the same here. So we're going to substitute x in the first equation. So in the first equation, we have 3y minus 3 is equal to -2x, right? So we're going to substitute wherever we see x, -9 over 2. So 3y minus 3 is equal to -2 multiplied -9 over 2. So 3y is equal to, let me take -3 to the right hand side to make it positive. So now we have -2 multiplied -9 over 2. Press the calculator. So we have -2 multiplied by -9 over 2. I don't know if you can see that. Okay, yeah, we can. So we have 9, right? So we have +9. And then 3y is equal to, we take -3 to the right hand side. So when you take -3 to the right hand side, it becomes positive. So 9 plus 3, that's 12, right? And then dividing both sides by 3, we get y is equal to 4. So we had found x to be -9 over 2. Now we have found y to be +4. If we look at the first example, indeed we had a point of intersection as -9 over 2 is to 4. I can confirm that with you right now. Yes, so in the first example, we had found this result, -9 over 2 is to 4. And the very same way, we have found -9 over 2 is to 4, regardless of which one we eliminate first, either x or y. So I hope that was helpful, and I hope that I made a difference in your life. I hope that I made a difference in the knowledge that we had in mathematics. So next time you have a problem with simultaneous equations, either you want to solve it with substitution or elimination, just go back to this video, and I hope that it will continue to make your life easier in terms of like solving these equations. I hope you have a great day.